Hello, I'm Neil Rickus and welcome back to another part of using tablets to teach programming in the primary classroom. During this session, we'll finish off looking at apps to enable us to teach the new computing curriculum, then examine how to use apps in the classroom along with appropriate pedagogy and finally assessment. Before we move on, just a reminder all the apps discussed during this session can be found on the grid at computingchampions.co.uk/MOOC. We'll first look at Hopscotch, which allows us to cover all the aspects of the 7 to 11 computing curriculum. I start by creating a new project and choosing a sprite, and at a basic level I can sequence instructions linked to different events. For example, I'm going to execute 2 of the built-in instructions wiggle and dance when I press the play button. I drag the instructions into the middle of the area, and when I press play, off he goes. However, as pupils' programming ability should now be progressing, they're expected to begin using features such as repetition and variables, so I'm going to use Hopscotch to produce an octagon and to count the number of sides drawn. As this program to achieve this involves a number of sections, I have to begin decomposing the program into smaller parts. Firstly, I drag the repeat block, which will be executed 8 times, then leave a trail of 100 pixels or little dots on the screen, and then a turn of 45 degrees. I'll press the play button to show you the results so far. I'll now include a variable, which is a data store in the computer's memory, to count how many sides have been drawn. In Hopscotch, I initially set the value of my variable, which I'll name sides, to 0, then increase the value by 1 after every turn. I'll also make sure that I display the value of the variable after each turn. You can see by looking at the screen that it's evidence that our programs are now becoming more complex. I'll press play so you can see the final result. I could then improve my program further by adding other sprites and producing more detailed images, such as in this example. The final app we're going to look at is Tinker, which is available for both iPad and Android. Tinker uses an interface similar to the popular desktop-based Scratch and has both play and create modes. Within create mode, our sprites have a number of characteristics, as seen here, which can be altered to customize our programs. With regards to the instructions I've entered for this sprite, I've used repetition in the form of a forever loop, which means the instructions will continue for as long as the program is running. I'll press the play button so you can see how this program in action before adding further complexity. Within this program, I can now add in selection or choices through the use of if-then statements. I'll add a nice background first, then an additional sprite such as this pink monster. Next, I'll add in an additional command to say I'm waiting, then change the text to I'm bored after 5 seconds. So within a forever loop, I'll create a variable named time, initially set it to 0, then increase its value every second. I'll then use selection to say if the time is equal to 5 seconds, say I'm bored, else say I'm waiting. Let's press play to see it in action. You may have also noticed that Tinker interface can respond to touch, so I'll add some code to change the sprite's costume when I tap him, which you can see when I tap him here. As pupils progress beyond primary school, Tinker can also be used for parts of the computing curriculum at secondary school level. For example, it allows people to enter functions, which is a set of instructions used repeatedly throughout a program, and Boolean logic through statements such as and, or not. So, when using these apps within the classroom, it's great if you can demonstrate the app to pupils before beginning work. The content on an iPad can be displayed on an interactive whiteboard using an Apple TV or software such as AirServer, or Android tablets can use a Chromecast. Alternatively, a VGA or HDMI cable with an appropriate adapter can be used. It's worth bearing in mind the app doesn't have to be used for the whole lesson, thus it could be used for a short period of time to introduce or reinforce a concept. It is therefore vital you're clear on your lesson's objectives and you're not simply using Hopscotch today. Where possible, differentiate your session content, such as through a pupil's starting point in the app or perhaps with a different app entirely. Using a scheme of work can assist with differentiation and help identify suitable progression paths for pupils. A scheme of work can also provide a range of pedagogies to use during your sessions. For example, the recently published Quick Start Computing identifies 6 techniques for use in computing lessons and emphasises the importance of revisiting and practicing concepts over a period of time, in addition to sharing experience with others. One of the problems with implementing a new curriculum, as we're currently doing in the UK with computing, is that assessment methods are often not fully defined. The UK government-funded Computing at Schools, CAS, provides a set of progression pathways which help identify pupils' understanding of different strands of computational thinking. For example, the screenshot here shows the initial progression for algorithms. Alternatively, Make Waves has a collection of online badges pupils can earn as their understanding develops, while Quick Start Computing again has guidance for primary teachers. However, one of the benefits of using tablets is screenshots can be easily recorded to provide evidence of learning. On most devices, this can be achieved by pressing the home and lock buttons at the same time. So, that concludes our sessions on using tablets to teach programming in a primary classroom. I hope you found the sessions useful and informative. Please don't hesitate to contact me if you have any questions about the content or like me to work further with you, such as working with your organisation to implement programming across the curriculum.